Okay, this is College Algebra, Unit 4, Expressions, Equations, and Functions. Today we're going to learn how to adjust your calculator window, and we're also going to learn how to solve equations using your calculator. So as we are taking a look at our calculator, we see that we can enter a graph. So we're going to go ahead and take a look at our window settings. So we're going to hit Window, and we can see that there's various settings in the window for the x-axis and for the y-axis, as well as the scale. So that's what this particular little graphing calculator reference is talking about. So you want to take a look at your graph and see what do my settings need to be in order to be able to see either the intersection, or to be able to see the minimum of the graph, or to see the y-intercept. Every time, if I hit zoom 6, then it will reset the graph to be a 10 by 10. So if I were to hit window, then I would go back to a 10 by 10 by 10 by 10 graph. If I hit zoom 4, it kind of zooms in a little bit on the graph to a negative 6.6, 6.6, negative 4.1, 4.1 graph. So it kind of makes it squared up a little bit. All right, so we're going to graph y is equal, I just hit y is equal to negative 1/2 x plus 11. So I'm going to hit negative, and then I'm going to hit alpha y equals, and here's how you can make a fraction, 1/2 x plus 11. If you do not have the function to be able to make a fraction in your calculator, then you can actually do it by just doing open parentheses, negative 1 divided by 2, then close your parentheses, then x plus 11. And that will work the same. So just consider that your fraction is actually a division problem. Okay, but I'm going to clear this. Now, if I were to hit graph now, okay, it leaves the window the exact same window that my last setting was. So it's not going to change the settings. So as you can see, when I hit zoom 4, I still have the same window settings as I had before. So it asks me to graph this function and adjust the windows so that I can see the y-intercept. Well, I already know that my y-intercept is 11. So I'm going to adjust my setting so that my y-intercept, or my y-max, is 11. Okay, now I can see it. Now if I wanted to see also the x-intercept, I started off with 15, but it looks like I'm going to need to go a little bit further. So I'm going to make my x max be 20. And now I'm missing it by 1. So we're going to make it 22. And now I'm going to be able to see both the y-intercept and the x-intercept. Okay, so let's record what our window setting is. So for x, I graphed it at negative 6 to 22 so that I could see the x-intercept, and then for my y window, negative 4, it's okay to just round off, to 11 so that I could see my y-intercept. Number 2 asked me to graph y is equal to negative x squared plus 30 and adjust the window so that I can see the maximum of the parabola. So negative x squared plus 30. I'm going to go ahead and hit zoom 6 to go back to a 10 by 10. And as I can see part of it, but I can't see the maximum, okay? My y-intercept is going to be 30. Here it is. So I need my window to reach a y max of at least 30. Let's make it be 35. Now I can see the maximum of my parabola. So my x window is negative 10 to 10, and my y window is negative 10 to 35. Okay. Now I'm going to graph this system of linear equations. 9x minus 25 is going to go into y1, and then negative x plus 105 is going to go into y2. So this is y1, y2. If I hit zoom 0, it adjusts the graph just enough so that I can see both of the graphs, but I can't quite see the intersection. So I'm going to have to adjust my x. Let's let my x max, because I needed to extend further in that direction. Let's let my x max be 50. That might be too far. But I can still see the graph. So second calc intersect, enter, 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 shows that I have my intersection is at 1392. So the point of intersection is 1392. So I could have adjusted my window so that my x max is just beyond 13. Let's make it be 15. And that my y max is just beyond 92. Let's make it be 95 and see what happens. Okay? You can just barely see it, but you can see the intersection. All right, we're going to do the same thing again, only this time what we're going to do is graph equations using solve equations using graphical methods. So we're going to solve the equation 5 is equal to 2x plus 3. So we're going to take the right-hand side of the equation and plug it into y1, and the left-hand side of the equation and plug it into y2. So I'm going to clear my data. 2x plus 3, 2x plus 3 is my y1, and 5 is my y2. Okay, I'm going to hit zoom 6 for a regular standard graph. Okay, so now I can take second calc intersect is 5, hit enter, 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 and I get that the intersection is at x is equal to 1, y is equal to 5. So the solution to this equation, which I had done graphically, is that x is equal to 1. If I were to do it algebraically, subtract 3 from both sides, then you get 2 is equal to 2x, divide by 2, x is equal to 1. So I get the same answer graphically as I get algebraically. So it's just kind of a cool, fast way to solve for equations. If you have a multi-step equation particularly, so this one is a multi-step equation, that has variables on both sides. So we're going to put the left-hand side into y1 and the right-hand side into y2. So we've got 1/2 x minus 10 is going into y1. Then negative 2x plus 10 is going into y2. We'll graph both graphs. Then you hit second, calc, intersect, enter, 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 and you can see that x is equal to 8. The directions for the keystrokes for your calculator are in the bottom right-hand corner. This is also number 6 of our examples. So if we were to solve this equation, we'll let the left-hand side be y1, the right-hand side be y2. So we've got negative 32 plus 4x is equal to negative 6 times negative 7x minus 1. And you'll notice that I'm entering it exactly the way that it's written. So I'm not even distributing, I'm not even combining like terms. I don't need to do that. I'm just going to solve it by finding the intersection. Okay. All right, I'm going to hit zoom 0. And now it will show me the intersection. It keeps the x window the same, but adjusts the y so that I'll be able to see it. Second calc intersect, enter, 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 and I get x is equal to negative 1. Okay, so here's some more examples. Taking a look at number 7, go ahead and solve 7, 8, 9, and 10 using a graphical method. So go ahead and pause the video and see if you can do 7, 8, 9, and 10 graphically. Okay. All right, so you might notice for number 7 that you got 2 parallel lines. 2 parallel lines means that they're never going to cross each other, and so that one is no solution. For number 8, you got the same line, okay, which is usually indicated by one line with 4 sets of arrows. The same line means that all real numbers are the solution. Okay, and then for number 9, I entered the left-hand side into y1, the right-hand side into y2, and then got that x is equal to negative 2. My window was negative 6, 6, negative 6, 6 for both the domain and the range restriction. Then for number 10, we got x is equal to negative 3. There's another way that we can solve for equations graphically, and that's by using their zeros. So the zero of a function is literally where it crosses the x-axis. So here we can see this linear equation crosses the x-axis at negative 1, and then this quadratic equation crosses the x-axis at negative 1 and positive 1. So what this means is when y is equal to 0, this is where it crosses. So it'd be kind of like in the previous page, we let y1 be the left-hand side and y2 be the right-hand side, or vice versa, and then we figured out where they cross. This time, we're going to let one side be 0 and figure out where it crosses the 0 or where it crosses the y-axis, so when y is equal to 0. So any number a for which f of a, is equal to 0, it's called the 0 of the function. If a is a real number, a is an x-intercept of the graph of the function. So in order to solve linear equations using their zeros, we need to put all the terms on one side of the equal sign and set it equal to 0. Then graph the equation to see where it crosses the x-axis by hitting second trace 0, and then give it a left bound, a right bound, and a guess. So for number 11, we need to add 20 to both sides of the equation, and we get 0 is equal to negative 4x minus 6x plus 20. I'm not even going to combine like terms. I'm just going to hit negative 4x minus 6x plus 20. And I'm going to try to see where does this cross the x-axis. I have entered it in incorrectly. Okay, I could tell when I had a quadratic instead of a linear graph. So here we can see that the graph crosses at 2. But how can I be sure of that? Because sometimes you might have a decimal. So you need to hit second, calc, or trace, which is the calc button when you fire the second button, and then go down to 0. Okay, then you need to get on the left-hand side of the 0, hit enter, then get on the right-hand side of the 0 by hitting the left and right arrows, hit enter, then hit enter again, and we can see that indeed it is true, the 0 is actually 2. All right, go ahead and do that for all the rest of them, moving the constant or the other variable terms, if that's what it is, to the other side of the equation and solving by finding the 0 of the function. Okay, hopefully you paused to figure out what these answers are. For number 12, the 0 is 0. So it crosses the x-axis at 0. That means x is equal to 0 for this equation. For number 13, x is equal to negative 4. For number 14, x is equal to negative 6. And for number 15, x is equal to 0. 16, x is equal to 1.